11.6b is about hypothesis testing. Make sure you pay attention because the book does things differently than I want them. I'm going to teach you a method similar to what we do in AP Stats. All right, so at the top of the notes, there's some steps that you can follow. I won't bother reading them to you, I'll just go through them. So let's read the problem first. A manager wants to advertise that the phone can surf the internet at least 24 consecutive hours. So I'll underline the important stuff. So at least 24 hours, that's what he's claiming. This looks like the N. He has a sample of 163. The mean from the sample was 23.6. The standard deviation was 1.2. And we want to test this at a 5% significance level. All right, so we start with our hypotheses. Those are HO and HA. HO. Your HO should always have an equal sign. So our HO in this problem is going to be, that's the Greek letter mu. Mu equals. And so the claim was 24. The number from the claim, I should say, was 24. Now, HA, this is our claim. So he claimed it could last at least 24. So our HA, our alternative hypothesis, is that mu is greater than 24. And the book likes you to say which one is the claim. Okay, so those are our hypotheses. The next thing we need to do is calculate the test statistic, in this case z. All right, so the formula for z is x bar minus the mu from your hypothesis. And then that gets divided by the standard deviation, which is divided by the square root of n. All right, you have two options. You could either calculate this by hand, or there is also a calculator shortcut. Okay, so doing it by hand, I'm getting negative 4.26. And the way you could check that with the program on your calculator, you could go to Stat, Tests, and it's the first option, Z-test. All right, for input, you want to choose stats. Data would be if they gave us a long list of numbers. And that would have taken a long time because in this case, there were 163 phones in the sample. So it's a good thing they didn't give us data or we would have had to enter 163 numbers. So choose stats because we had summary stats. For mu, we're going to put 24. For sigma, 1.2. X bar is 23.6 and is 163. On the second to last line, we want to choose the greater than symbol and then calculate. All right, so if you do that, that confirms that the z is negative 4.26 if we round to the nearest hundredth. All right, after the z, it's really important that you report what's underneath it. Now the calculator just says p, but you should write p-value. So the p-value in this case is very close to 1. So it looks like it is 0.99999. So if I write 5 nines, then I am correctly rounded. All right. So the last part, or I should say the next part, you need to compare the p-value to the significance level. So in this case, our p-value is greater than the significance level. So right here, this is greater than 0.05. I converted the 5% into a decimal. So since the p-value is greater than the significance level, whenever the p-value is large, you fail to reject. So I'm going to write a short sentence and say we fail to reject HO. So again, if the p-value is greater than the significance level, you fail to reject HO. If the p-value is smaller than the significance level, you are going to reject HO. All right, so we fail to reject HO. And whenever you fail to reject, your final sentence should start with, there is not enough evidence. Okay, so the final sentence should be about HA, but in words. So if you fail to reject HO, there is not enough evidence of HA. But what is HA in words? HA is there's not enough evidence that, and then put HA in words. There's not enough evidence that the battery lasts at least 24 hours before needing to be recharged. Okay, on the back, Josh and his sister Megan run a mile each day together. Josh thinks that they run the mile under 7 minutes. Megan thinks it takes longer. All right, so they time themselves for 20 days. Let me underline the important stuff again. Their mean is 7.4. Standard deviation is 0.2. All right, and this part's important. We're testing Megan's hypothesis at a 10% significance level. All right, so we start with our hypotheses, HO. Remember, HO always has an equal sign. So our HO is going to be mu equals, all right, so the number that someone is claiming is 7. Now they're not claiming that it equals 7. We're testing Megan's hypothesis. Her hypothesis is that it's greater than 7. So I'll put in parentheses here that this is our claim. After our hypotheses, we need to calculate the z. So the formula for z is you take the average from the sample. So the average from the sample was 7.4. You subtract the hypothesized number, which is 7. Then you divide by the standard deviation divided by radical n. So how many observations were in the sample? There were 20. So n is 20. All right, and calculate this. So you actually have to use the calculator program for this because although you can do the z by hand, you can't do the p-value by hand. So we need the calculator to figure out the p-value. So go to stat, test, z-test, choose stats on the first line. Our mu is going to be 7, sigma is 0.2, x bar is 7.4, n is 20. And then on the second to last line, you choose the symbol that's in the HA. So the HA has a greater than, so we choose greater than. Then we hit calculate. All right, so you get that the z is 8.94. Then you also have to report the p-value. So our p-value is essentially 0. It's 1.899 times 10 to the negative 19th. All right, so we always compare that to the significance level. In this case, it is lower than the significance level of 10%. All right. So since the p-value is smaller this time, we are going to reject HO. So important things to notice. Your options are either to reject or to fail to reject HO. You do not have the option of accepting. It's either reject or fail to reject. So we reject HO, and whenever you reject, there is enough evidence. And remember, this last sentence needs to be about HA, but put that in context if you can. So we're going to say HA, which is mu is greater than 7, but we're going to put that in context. So there is enough evidence that they take longer than 7 minutes. To run the mile. Okay, let's do one more. Okay, well, the HO and the HA are already stated for us. So I won't bother rewriting this because that's the first step. All right, so I'll pick it up after that. Then we would calculate the Z, and I'll show my work for that. So Z is the observed sample mean minus the hypothesized mean. And you divide that by the standard deviation, and that gets divided by the square root of n. All right, now we go to the calculator, stat, tests, z-test, the stats. All right, so mu is 89.3, sigma is 1.5, x bar is 89, the n is 100. The symbol we want, so looking at HA, we want to choose less than and calculate. So the Z is -2. The p-value is 0.0228. Now that is slightly greater than our significance level. All right, so if the p-value is large, you fail to reject HO. And whenever you fail to reject, there is not enough evidence. And this last sentence is supposed to be HA in context, but we don't know what HA is in context. So I guess the best thing we could do is just say that there is not enough evidence that, and we'll just write HA in inequality form. So there is not enough evidence that mu is less than 89.3, and that's all we can say because we don't know what this problem is about. All right, and that's it for 11.6b.